The structure of the universe. In this video, we will mainly discuss the structure of the expanding universe. Also, here we begin with the Big Bang Singularity. Here I propose a structure that is formed by the regular interactions between energy and the space-time in which it resides. This idea is mainly concentrating a gravitational frame of the universe. Space-time is absorbing to the center of the frame, so it can create a singularity at the center of the frame. A singularity entirely opposite to the Big Bang Singularity, and I wish to call it as the space-time singularity. And this structure is mainly depends upon the gravitational frame of the visible universe. This video is part of a series of videos describing the entire universe. I am starting from the early stages of the universe before the Big Bang. I am discussing the various situations for the formation of the Big Bang Singularity. Then the cause of Big Bang at that particular time is also explaining here. In this video series, I discuss the subsequent Big Bang, the expansion, the structure, and the end of the universe. I illustrate all this with the help of a new concept that I have developed from my studies. Usually when we look at a picture of a singularity, we can see a cone and a sphere at its base. This refers to how much that the singularity is curving the space-time down into it. This is just a two-dimensional picture. It also misleads us as to the meaning of the picture. Here we see a flat surface bent into a singularity. But the space-time is never a flat surface. It can only be a flat from perpendicular to anywhere we are looking. If we look upward from the Earth, it may seem that the Earth is just below the flat space-time. It can be said that the Earth is bending the space-time into it. The picture is very true for us. At the same time, if we were looking at the moon from the Earth, this picture would have been very absurd. We view the moon as an object in the space-time. We can see that there is space-time around the moon. It must be said that the moon bends the space-time into it from all its sides uniformly. Because the moon is a spherical object, it is said to be, it can curve the space-time at same from all its sides. Now, if more energy is distributed to a particular part of the moon, that part will be able to curve more space-time over there. We can only experience the flat space-time perpendicular to the point of view. The moon is dragging the space-time from every side of it and hangs in that curved space-time. The moon creates a new curved space-time inside the curved space-time created by the Earth. This is what the Earth also does. The Earth and the other planets are creating a new curvature inside the Sun's curved space-time. Where the energy is located, it pulls the space-time into it and creates a curve and hangs in that space-time. Here we have seen that three objects create curves in the same space-time. If the Sun disappears the next day, the Earth will be slipping from here. But it will find a place to stay somewhere else in the space-time. This is how energy and space-time react to each other, and energy creates a consistent place in the space-time to stay. This is what makes the space-time as the fourth dimension. Energy is staying in the space-time. Energy will always have some space-time of its own. Let me give you an example to understand it quickly. Suppose you have a steel ball weighing 1 kilogram in your hand. Suppose that spherical ball has a diameter of 5 centimeters. The space required to form a sphere about 5 centimeters in diameter is the own space of the energy contained in that ball. We can make this ball as smaller or larger. We do not have to think about that. What we need to understand here is that energy needs some space-time to survive on its own. Wherever the space is, it will have a length. So it requires some time to reach that length. That is why space and time together become a dimension of space-time. Let us now return to the Big Bang Singularity. Now we have an idea of how space-time accommodates singularity into it. I have already explained these things in my previous videos. So let us think about the structure of the universe. What may be the structure of the universe? This is a concept that I have already published in a journal with the name of the structure of the relatively accelerating universe. Here I am trying to refine that idea and make it more comfortable. I view the universe as two different systems. One is an energy-filled singularity and the other is the curved space-time by the singularity. Both of them are finite. This is because the energy within the singularity is finite. A finite amount of energy can only bend a finite amount of space-time. Here we can consider the singularity as a sphere. Then the curved spacetime by the singularity also can have a spherical shape. The energy within the singularity is unified by the strong gravity. It is by the same gravity that creates a strong curvature in the spacetime. So these two together can be considered as closed systems. This system has no gravitational relationship with the space outside it. So the whole space-time within this system is interconnected. So if there is an imbalance somewhere in this space-time, it will affect the whole system. The picture, the gravitationally closed frame of the universe. The red sphere in the figure indicates the singularity, and the grey sphere indicates the curved space-time area of the singularity range. And the outer part of it is free space beyond the limits of the singularity. This picture has three parts. The first is the red sphere at the center of the image that shows the singularity. It is willing to absorb the outside energy until the moment of the Big Bang. A major cause of the Big Bang is that the singularity absorbs energy from the outside. So the gravity of the system will also increase. The increasing gravity puts more pressure on the surrounding space-time. That will lead to a more curvature in the space-time. This has been discussed in the previous video. All these situations are well described in my book, The Key to the Secrets of the Universe. You can see the evolution of the universe from the primordial stage until the destiny of the expansion of the universe in my book. There you can see a lot of new ideas on the expansion and the acceleration of the universe and about the gravitational interaction. I am explaining there how the expansion of the universe is undergoing another Big Bang. You can find the link to the book in the description box. Let us look at the second part of the picture now. The second part of the image is the space-time around the singularity. We know that the space-time is over-compressed with strong gravity. The more energy absorbed by the singularity will also increase the area of the curved space-time. When the singularity can curve more space-time, the energy present in that region also becomes under the control of the singularity. The surrounding space-time is creating favorable conditions for the growth of the singularity. This process increases the energy of the singularity until the Big Bang. The interactions of the space-time and the energy are the basis of everything what we see today. However, the curved space-time acts as a conduit to channel energy into the singularity. The energy that is absorbed by the singularity from outside is transported to the singularity through the curved space-time surrounding it. Therefore, the presence of outside energy can occur anywhere in this area. Sometimes it can be small forms of energy, while some other times they are large forms with a lot of energy. Since the singularity was absorbing energy until the moment of the Big Bang, there would still be such forms of energy in the space-time. The energy that was sustained here did not participate in the Big Bang. When the energy of the singularity is pumping into the space-time after the Big Bang, the energy which remains in the space-time will become part of the universe. The third part of the picture is also represents the space-time, but it is not under the control of the Big Bang singularity. We do not know how extent is this. We do not know even how much energy is still in this space-time which is not a part of the singularity. By absorbing more energy, singularity takes control over this place progressively. As more space-time is controlled, the singularity is able to absorb more of the energy present there. If it starts this process once, then it is impossible to stop. For this to end automatically, the singularity must be absorbed by the whole energy present in the space-time. Otherwise, the singularity should make a curve on the entire space-time. If this is the case, there is no chance for the Big Bang, because then there will be nothing to create an imbalance. Then we can assume that the Big Bang took place before all the energy and the space-time in the universe were merging. We know that our universe is expanding rapidly. The universe can expand only to a finite space-time where it was influenced by the singularity at the time of the Big Bang. A finite space-time does not mean a very small space-time. Studies suggest that our universe has been expanding for about 13.8 billion years. This process may continue for billions of years more. We can already see how far space-time has been influenced by the singularity. To understand this, we must have to understand the structure of the universe. The phenomenon of singularity is being eliminated with the Big Bang. The singularity is broken and the energy is liberated. The energy was spreading into the space-time and naturally the space-time will enter into the singularity. The important point to note here is that the energy existing from the broken singularity has a common gravitational attraction to each other. It is this very characteristics that underlies the formation of the structure of the universe later. This is precisely what accelerates the current universe expansion. Let's try to explain the singularity that was devastated by the Big Bang with the help of a picture. Picture the broken singularity. The picture indicates the spread of the broken singularity into the space-time after the Big Bang. The state of the universe must have remained this way until the structure of the universe was formed after the Big Bang. A sphere splits into several parts and disappears to all sides uniformly. We can quickly realize it with the vision we have in the sky when a firework shows. We can see that the fire spots spread across the sky on all the sides uniformly. This situation is almost identical to what happened after the Big Bang. So the energy begins to expand into the space-time again. Rather than the other models of the Big Bang, here I am taking space-time as an important factor. We are discussing the impacts that created in the space-time after the Big Bang. The influence of space-time to encourage the Big Bang is also an important factor here. At the very Big Bang moment, there was three important changes happening in the singularity and the space-time. These changes encourages the inflation era. The things that have happened in the Planck era are also discussed as the interaction between space-time and the singularity. As I feel the Big Bang as a breakdown of the singularity and the space-time, then it can never be an explosion. What is happening here now is quite the opposite of what happened in the Big Bang singularity. At first, the forms of energy scattered over the space-time joined together and to create a singularity. Now again the same singularity is decomposed and the energy is spreading into the space-time. But now the energy is not being in the previous stage. It had an exact evolution. Now the situation is conducive to the evolution of the energy. This was largely due to the extreme temperature during the Big Bang and the subsequent phase-to-phase temperature change. Now at various stages energy can be transformed into particles, antiparticles, atoms and molecules. Although all of this will happen at different time intervals and we can see an evolution of energy is there. Space-time is creating a favorable conditions for the evolution of the energy at each stage. The significant changes in the temperature of the universe after the Big Bang are due to the interactions of the space-time. We all know that the evolution can happen only when there is a favorable condition. Charles Darwin's theory of evolution explicitly explains it. The beginning of life on Earth is due to the interaction of the environment. If the nature were not favorable, our Earth also would be as barren as other planets. Here we can understand that the universe always has only one law. The basis for all this is the collapse of the singularity without any immediate warning. It creates a strong impact on the space-time. In any case, now we can think more about the creation of the structure of the universe. Since the energy within the singularity was compressed by strong gravity, we can assume that it was a sphere. The key challenge for the space-time is to fight with the gravitational collapse caused by the Big Bang. The singularity keeps the space-time curves together, but the situation will suddenly be altered by the Big Bang. Singularity, which breaks into several parts with the Big Bang, will create different curves in the space-time. Depending on the amount of energy contained in each part, it will begin to create a curve in the particular space-time. If the singularity were to exist always in the same place in the space-time, the new forms of energy created by the Big Bang start a continued journey through the space-time. They do not create any curvature in a permanent place in the space-time. Depending on the changes in their position in the space-time, the position of the curvature which they create in the space-time also varies. The space-time is undergoing continuous changes here. In addition, the massive temperature generated by the Big Bang is also spreading into the space-time. These constant changes in the space-time and the common gravitational attraction of the total energy present there led to the creation of a new structure for the universe. Although the singularity was broken, the energy forms that spread to the space-time always kept a common gravitational field. Therefore, it can be said that the universe developed from within a general gravitational shield. This situation of the universe still continues. If the gravitational shield collapses in any case, then our universe would be entered into a new state. It may be a big crunch like the Big Bang. This may lead to the reconcentration of the energy into a particular space-time, or it may create isolated universes. Each of the galaxies separated by the gravity will remain as a separate universe. We will discuss the future of the universe later. But from my ideas, I can say that it is creating a singularity at the center of the universe. A singularity entirely opposite to the Big Bang Singularity. A singularity of space-time. Also, because of this common gravitational attraction of the objects in the universe, the expansion of the universe has to be end already, or it must decelerate its speed of expansion. But we know that neither of these things is happening here. Here the universe is expanding at an accelerating rate. The universe is penetrating very fast into the space-time. The universe is still moving through the space-time that was within the range of the Big Bang Singularity. New energy can only be added to the universe if it goes beyond this range of the space-time. However, this has not yet happened. So the structure of the universe must be appropriate for this. Here I present a cosmic structure that explains the acceleration of the expansion of the universe. We can learn more about it with the help of a picture. The structure of the universe. The most inner part of the picture is the center of the universe. Let us call this as the absorbed space area. The outside of it is our visible universe. The outermost part is called the outer space. The picture has three parts. Let us examine each one separately. First, let us try to understand in detail the section marked as the visible universe in the picture. Naturally, this is the universe that we can see and understand. All of the energy present in the singularity is distributed in this region. All the stars and galaxies we see today are located in this region. We have learned that the objects located in this region are moving away from each other rapidly. The entire gravity of the universe is centered on this region. Then let us understand the outermost part of this image. Let us call this part as the outer space. Our universe is expanding to this region. We do not know how wide it is, so we can classify it into two. The first is the space-time under the influence of the gravitational field of the universe. This was the space-time that is curved by the Big Bang Singularity. The universe can expand to this large extent as a system with a common gravity. Beyond that, the common gravitational field of the universe will be shattered. In this part, we can expect the presence of energy forms that did not participate in the Big Bang. We can assume that our universe has not yet grown throughout this region. Beyond this is the space where the common gravitational field of the universe cannot exert a strong influence. As the universe expands, the gravitational field may be spread into this space-time also. But it will not be able to keep the universe as a common system of gravity. Also, in this region, the presence of the energy forms that did not participate in the Big Bang can be expected. This area has no importance to us regarding the present situations of the universe. Now let us have a look at the center of the image. Let us call this part as the absorbed space region. This part is the center of our universe. Only space-time separated from the universe can be seen there. There is no other kind of energy present there. Let us see how this structure came to be. The main reason for this type of the structure formation of the universe is its common gravitational attraction. Let us examine it in detail how. With the Big Bang, the energy that was together in the singularity started spreading into the space-time. At the same time, energy retains its common gravitational field. So let us see how the center of the universe loses all its energy and retains only space-time there. There is an argument that the center of the universe is a very strong black hole. But I do not agree with that. A black hole is possible if there is some kind of energy. There are two main reasons for this. First, the immense force that created by the Big Bang. The Big Bang created a force stronger than we can imagine. As a result, the energy continues to flow into the space-time even now. Such an immense force would leave nothing at the center of the source. It will scatter all the energy out of there. Even if it did not happen, the gravity would not allow any kind of energy over there at the center of the universe. The whole energy present there is attracted to each other by gravity. As such, the energy at its center is attracted to the energy above it. Then spontaneously, the displacement of energy above will always affect the energy forms below of it. The energy is moving forward due to the Big Bang. This movement will also strongly affect the energy behind it. When this happens, no energy is likely to be left at the site of the Big Bang. As the energy spreads throughout the space-time begins to separate and condense to its center. What we saw in the first video is that the singularity is formed by the combination of energy scattered in the space-time. The opposite is happening now. The energy of the universe creates a gravitational framework between the absorbed space-time and the outer space. The universe is expanding with the gravitational frame. Therefore, the gravity never acts against the force created by the Big Bang. There are no energy forms in the center of the universe. If you pay attention to the picture, you will understand it. There is only absorbed space over there. So gravity does not strongly intervene at the center of the universe. The gravitational attraction is between the energy forms inside the frame. Therefore, the gravity will be concentrated within the frame itself. So it must be said that the gravity is moving in the same direction as the force created by the Big Bang with the frame of the universe. According to Newton's first law of motion, an object that remains in a state will remain in the same state as long as no force acts on it. If the object is either at rest or moving at a constant speed, the condition will not change. Here the rate of expansion of the universe must remain constant as gravity does not create any adverse conditions in any way or any other force does not exist to prevent it. But we know that the expansion of the universe is accelerating. Now let us look at these causes in detail. For that, let us look at the process which by the structure of the universe is formed. The singularity shattered by the Big Bang is spreading into the space-time through all its aspects. Then the space-time will enter into it with great force. As energy spreads into the space-time rapidly, the space-time enters to the broken singularity at the same speed. This will create the favorable conditions for the space-time to reach at the center of the broken singularity. Gravity will make attempts to hold the whole energy together. This action removes the energy from the center of the universe. Thus, a gravitational frame is formed that holds all the energy in the universe together. The main question that arises here is, if the universe is within such a gravitational frame, why do the energy forms within it move away from each other? We know that as the universe expands, so do the stars and galaxies within are moving away from each other. Gravity will not work against the expansion of the universe, but will try to prevent the energy to moving away from each other. I regularly use the word energy here to represent the stars, galaxies and every other things which presents in the universe. We can see that the interactions between outer space and the absorbed space plays a significant role in the increase of the distance between energy forms and the acceleration of the expansion of the universe. Let us see how that happens. The expansion of the universe is the expansion of the gravitational frame. The gravitational frame grows larger and expands into the space-time. This process reduces the force of mutual attraction between the energy forms within the frame. As the universe gets bigger, also it moves away from its center. This will allow more space in the center. That is, as the universe expands, the space-time it acquires is absorbed into the center. This is clear from the picture above. When the outermost parts of the gravitational frame expand into the outer space, the space-time that enters inside the frame reaches to the center of the universe. Space-time also travels inside the frame at the same speed as the universe expands. Because the outer side of the frame is larger than the inner side, it will allow more space to fit inside the frame. This unbalance will transfer more space-time into the center of the universe than its allowed limit. This will create more pressure on the space-time at the center of the universe. As the pressure of the gravitational frame increases, the absorbed space-time at the center of the universe will be forced to contract automatically. The shrinkage of the center area causes the space-time within the gravitational frame to expand. As I mentioned earlier, the space-time is very flexible. Therefore, this process is easily possible. So, the center of the universe, which is incredibly shrinking, will change to a state similar to that of a singularity. If the cause of the Big Bang singularity was the energy in the form of the primordial particles, here it is simply that it occurs in the absorbed space-time. At the same moment, the space-time will begin to apply its pressure to the inner side of the gravitational frame of the universe. So we can see that the absorbed space-time will push the gravitational frame from the center of the universe. Now we see that there is a new force is being created to help the expansion of the universe. This push from the center of the universe will accelerate the speed of cosmic expansion. This came to answer the questions that we already had before. We had previously suspected that the attraction of the forms of energy within the frame would slow down the expansion of the universe. The newly formed force will help to overcome this condition. Another possibility for the acceleration of the universe can be represented with the help of an image. Cosmic development at constant velocity. This picture illustrates the increasing distance between objects traveling at equal speeds. This is an idea that even if our universe is expanding at constant speed, then let's see how the rate at which galaxies move away from each other increases. Our universe began with a spherical shaped singularity. Let us take the Earth itself as an example to make the idea clearer. Suppose that you are throwing a stone in an upward direction. You throw that stone perpendicular of the Earth. Imagine that your other two friends are also doing the same thing from the two parts of the Earth. Now the trajectory of those stones will be as seen in the picture. The figure shows three objects traveling at the same speed at the same time from different parts of the surface of a sphere. When this happens in such a manner, we can see that they never travel in a parallel direction. Their trajectory will be in the same as in the picture. The universe after the Big Bang also expanding in the same way. We can start from a certain part as shown in the picture. The picture shows three objects moving at equal speeds. Let us choose 3 points A1, B1 and C1. These points should actually be selected spherically. But I prefer these points here in a straight line to make things easier to understand. If we select these points in the sphere, we will feel that two objects are traveling a lesser distance than the other one. This will create an ideological confusion for us. If three objects travel at equal speeds, they will travel the same distance at regular intervals. Now we can imagine that these three objects reaches point A1, B1 and C1. We can see that there is a clear distance between these three objects. They travel at the same speed again and reach the next point A2, B2 and C2 within a certain time limit. They traveled the same distance at the same time interval, but the distance between them is increased. The distance between A2 to B2 is greater than the distance between A1 and B1. We can see this is happening again its journey ahead. Here the speed never increases, but the distance between them always increases. So someone who observes their motion may experience an acceleration on its speed. Perhaps this is how the stars and galaxies in the universe are moving away from each other with the rate of acceleration in their velocity. Anyway, let's stop here. Now let's see what the future holds for the expanding universe in my next video. And thank you for watching my video.